And of course, on screen we have Dr. Ann Summers, who's with us. Welcome, Ann. And if you have any questions for Dr. Lavoie or Ann, please don't hesitate to come up.
Okay, Stephen, I told you I was going to ask you this. You mentioned in your presentation that 3 micromolar will do all these changes to the bacteria, and I just want to know if you've given consideration to that relative to the dose that you may get from 4 or 5 mercury fillings after swallowing a cup of coffee.
After what was
Swallowing a cup of coffee, heating up the amalgam to increase that, or whether it's the debris that comes in. I don't know how much mercury is swallowed. So, but it would hit the gut. So maybe Ann has an answer to that too. Mike?
Yeah.
Nice and close.
So you asked earlier, or you gave me a number actually of how much, and I don't remember what the number was that you said.
27 micrograms.
27 micrograms? Okay.
Per day.
Okay, per day. So I'm pretty sure that 3 micromolar is around 600 micrograms per liter. And so it is probably higher, but these conditions were also determined based on if I add this mercury to these cultures at a slightly later point in the growth rate, then it's going to have less of an effect, or if I hit them slightly earlier, it might kill them. And so that's why the subacute that I defined for this experiment was just based on my experimental conditions. And so I'm not sure how to necessarily say how well that applies to how much you might be exposed to from an amalgam going through your GI tract. And so, yeah, because converting concentrations and things like that are just always difficult.
Yeah, just in a practical sense, it would be interesting to know that. And you got to aim your camera down so we can see your beautiful face. Ann, can you hear us? There you go. There you go. Oh, hold on, Ann. We're not hearing you. There it is. Sorry, can you just start again? Can you hear me? Can you nod your head? Okay.
It was working before.
We can't hear you. Hang on.
Bandwidth problem.
There we go.
So I think if we just go to audio.
It's okay now.
We hear you now. Whoops.
Yeah, but you're freezing. In other words, I can't hear you.
Okay, so you can just,
Okay,
anyway.
you want to look at this? And let's ask another question. And perhaps we can get to Ann after that. Is that okay?
We're going to go to audio.
Yeah,
Oh,
It doesn't take as much.
okay. We're going to use another way to communicate with you here, Ann. Just hang on a sec. In the meantime, could I ask Dr. Flakas, do you still recommend Lugol's as a good source of iodine?
Lugol's liquid, about 20% of patients develop gastritis from it. So it would be better to take an oral tablet where the incidence of gastritis is like maybe less than 2%. So it just depends upon the individual. And if they can tolerate the liquid, great, because of the financial issues. But if they develop a gastritis, then it would be better to go with an oral tablet.
Thank you.
Are you up there, Ann? No. We can hear a fuzz. We'll get back to you.
Any more questions? Would you come up? Simply come up here. Anyone that has a question, for those who've just arrived, please come up, take the mic, ask your question.
Thank you. Just on the same topic, iodine pills or drops versus putting it on your skin.
Sorry, would you say it again?
On the taking of the iodine, as far as topical application to the skin.
It's a poor way to go, because if you put iodine through the intestinal tract, you get 100% absorption. If you put iodine through the skin, you get less than 7% absorption. 93% of it evaporates into the air. So putting iodine on the skin is a very poor way to try to saturate the body with iodine.
Thank you. But on that note, as far as iodine killing a lot of the microbiome, and I'll take that up.
Iodine does not kill the microbiome of the intestine.
Dr. Fletches, again, if you would, you mentioned early menopause at one point with the PQQ maybe being helpful along those lines, and maybe the melatonin also, in combination with that. I don't know if that would be helpful. My sister's 35 years old, going through menopause and wondering what's going on. What do you have a brand that you recommend that combines the coenzyme Q10 and the PQQ, or where do we have you found one that's good and trustworthy? And a dose?
Where do you live?
Utah.
Where? Utah. Yeah, there's a company outside out there that you can talk to. They have a very trustworthy PQQ product. I would try them first because I know that their product works. And then one of the side effects of too much, melatonin you have to worry about is that there was a company in the Netherlands that was making a melatonin birth control pill. Melatonin at 60 or 70 milligrams per day will turn off the ovaries and stop all steroid production from the ovary. So they were building melatonin 60 to 70 milligram tablets to use as a birth control pill. So you have to, with younger women, you need to modulate down the production of melatonin the melatonin exposure. One thing that Frank didn't say is that, and it's in the medical literature, is that if you get too much melatonin in the body, it'll knock out your sex drive. So take it from there. You just have to, you have to put the melatonin in perspective as to where, what your priority is as far as what you want to do.
Well, and I think you mentioned over 50, he would really recommend people take it more. And so,
what I would do is because melatonin helps you to sleep. And in fact, this is a study that was done in Milan, Italy, back about 25 years ago. The Italian government was looking at the healthcare issues of blind people. And the Italian government went to Milan, Italy, and they surveyed all the blind people in the city of Milan, and they said, what type of health problems do blind people have? It was interesting that in Milan, Italy, none of the Italian blind people had cancer. And that's because blind people, if they can't see light, they have a continuous exposure to melatonin all the time, and the melatonin is cancer static. It inhibits the ability of the body to make cancer, which is why blind people don't die of cancer, which explains why every woman above age 50 that I would say, instead of giving her a pill to put them to sleep when they complain about insomnia, you put them on melatonin to help them get some sleep, and at the same time you're doing her the favor of putting her on something that can inhibit her ability to make cancer. You want to comment on that?
Yeah, we could add also that it's a working theory out there, has been for the last 10, 15 years, that as your melatonin peaks around the age of 18 to 20, really high levels that are being produced at that point, and then it goes down in kind of a linear fashion till you hit 40, and then it goes down in a logarithmic fashion. So by the time you're like 50-ish and beyond, there's almost none there compared to what it used to be. And a working theory is that what induces ovarian failure in menopause is this deficiency of melatonin. Not to say that if you give a lot of melatonin, which I've done this, you don't perpetuate ovarian function. It goes down anyway. But the thought is that that's the trigger. So when I give hormonal replacement, there's a couple things I'll tell you about. For women now, I'm talking about for women. When I give hormonal replacement for women, and I'm talking about bioidentical hormonal replacement with estradiol, estriol, progesterone, testosterone. If I add DHEA and melatonin in there, I knock down probably 90% of any of the potential issues women complain of. Well, it didn't work this or didn't do that, or I'm getting acne or this, whatever. When you put women on bioidentical hormones, you always go through this phase where you're trying to suit it for them. But if you add melatonin and DHEA in there, it sort of absolves you of many sins. And the whole process works out pretty well, and I'm pretty convinced that I think it's interesting what Jorge said over here about melatonin, causing ovarian suppression. I'm gathering that those birth control pills didn't work so well, or we would have heard about it. And there's probably nothing that's more libelous than having a birth control pill that doesn't work so well. Anyway, if it really worked that well, we would probably be. The truth is, though, I just don't end up giving a large dose of melatonin other than to women that are already pretty much at the end of their menstrual game anyway. Just some extra thoughts.
I have a question for Dr. Yu. I really enjoyed appreciating your reasoning here to get to the decision to have stainless steel crowns for your child this morning. Had anyone recommended or suggested the use perhaps of an Ormosur? And if so, what is your opinion on Ormosurs versus BPAs in the quantity of BPAs in composites? I'm curious to find out. And finally, have you considered the nickel content in stainless steel before you made your decision?
Very nice questions. And as I said this morning, for me, it's a struggling path. Try to select the best choice for my son. So we had discussed several options, and Dr. Simon Lin, and he is aware of the potential. Of course, it's very clear amalgam is out of the choice. And then we're thinking about BPA. So I did a lot of basic scientific mechanism studies using BPA, and also we compare BPA alternative using in the composite. So in my lab-based basic research, we found BPA alternative, some form, have much more strong toxicity as compared to BPA itself. So a lot of time you see sunset BPA-free products, don't believe it. So some alternative, much more toxic than BPA. Then through this study, so I'm struggling, and at the same time, I start look at, using the enhanced data, try to look at the long term. I know the short term, mercury after surgery, you have a surge. And for this study, I want to look at the long-term impact from after months, years, and compare, because I'm more concerned chronic low dose. And for the case of BPA, we know after surgery, you can find BPA increase in urine. But this study found as a whole representative US population, we didn't see increase as compared with dental surface or dental surface filling. So that's convincing me BPA composite might be a good choice for that time. And then why we finally select the stainless chrome. We aware, because I did a lot of metal, nickel, cadmium. I know that potential, especially made from the products from less quality manufacturing. So we discussed that option, and finally Simon said, I had very high quality chrome, so should have no issues of nickel or other metals. And of course, as I said, we concerned about, a lot of surgery to put the crown. They needed to put 4 years old kids to sleep. And that's all the clinic. We went to 6 clinics. All of them required that. Otherwise, they said they cannot cooperate, work with the kids to put 6 of crown into the teeth without doing any anesthesia. And Dr. Simon said, well, let's try. Talk to you, Zach, and to see can he handle. And in fact, we go through, put all 6 crown without any anesthesia. That's also because I'm a toxicologist. A lot of studies reported they have whole body anesthesia linked to the autism or anything other kind of things. And then, so that's the answer, how nickel, and we keep monitoring. And after put the crown, we'll check the gum tissues. If there's nickel, and then they will have some reaction. And in fact, after the surgery, the operation, we didn't see any changes. Right now, Zach is 10 years old. All the teeth, gums, healthy without any problem. And very beautiful. Even he got lost one, because the baby teeth, and we checked that the structure of the teeth, perfect, nothing. It's very clean. Thank you.
Dr. Haley just joined us in the panel. Any questions? Would you like to come up here, please, and take the mic? Thank you.
Thank you. Question regarding methylation SNPs and mercury and heavy metal elimination for Dr. Haley and the experts in the panel, please.
I didn't. You have to pardon me, but I didn't hear your question. I didn't get it.
The effect of methylation SNPs as it affects the elimination of mercury, organic or inorganic mercury through the system.
Well, you mean methyl mercury?
Both.
SNPs.
Oh,
Methylation SNPs.
Well, I mean, with regard to the compound we're using, it's not involved in doing that. I mean, that's involved in the uptake and the natural excretion, but it doesn't have anything to do with NBMI binding or removal. I may not be getting the essence of your question, but
my question is not regarding OSR. It's regarding the general elimination of mercury. How is it affected by methylation SNPs?
right here.
I think you're talking about methylation SNPs, SNPs. Okay. SNPs are single nucleotide polymorphisms. That means they're a single alteration on a gene, which means they don't mean a lot. I think they're extremely overrated. But what they do is they give you kind of an idea. It's better than completely rolling the dice. Not much better, but it's better than rolling the dice. If you have a methylation SNP, there's a chance that you're going to have a problem with the methylation process, more likely than another person who doesn't have the SNP. But you could have perfectly good methylation. So that's the first thing to understand. But let's say that you really do have impaired methylation. Methylation works hand in hand. It's done in the mitochondria. Methylation works hand in hand with oxidative phosphorylation. In other words, if methylation's not working, oxidative phosphorylation doesn't work, and vice versa. As the two work together. And it's pretty clear that mercury is a mitochondrial suppressant. So it's definitely going to affect methylation. And the other thing about mercury is, as you probably know, it ties up the methylation of cobalamin. And so the more mercury you have, that's going to interfere directly with the methylation process. Does that help?
Yeah.
Okay.
Tremendously. Thank you.
And you want to add?
Questions, please come up here and use the mic. Thank you. Robert?
Well, I could be wrong about this, but I wasn't aware that mitochondria that any eukaryotic cells will methylate mercury. I think that's a bacterial specific process, as far as I'm aware. And I mean, the genes for doing the methylation have only recently been discovered. And I think that you were mostly asking about elimination from the body. So I think you were trying to ask what effect. I guess that's where I was getting lost. I was unfamiliar with this methylation SNP term. And so maybe that's why I didn't understand the question. But as far as being exposed to methylmercury, that methylmercury can be demethylated by bacteria in your body, as the same as inorganic mercury can be methylated by the bacteria in your body. And those do affect the rates that it will be excreted. Inorganic mercury is typically excreted faster than organic mercury. But I think nearly all of the mercury that's actually excreted out in urine and feces is primarily observed as being inorganic mercury, because it becomes demethylated as it goes through the GI tract, and actually because it's more soluble and will be excreted more easily that way. So does that help at all? Or I guess I'm still not familiar with this SNP term. So.
Yeah, I think that methylmercury is not the question. It's about methylation in general. And there's this cycle called the methylation cycle. In order for that to work, you have to have methyl B12. And mercury interferes with the methylation of B12, and therefore can potentially shut down the methylation cycle, which is something that's necessary for optimum function of a mitochondria. So basically, via that mechanism alone, can shut down mitochondrial function.
Just one comment. In humans, when you don't have methyl B12, you can't make acetylmethionine. And acetylmethionine is used to methylate DNA and all the proteins in the eukaryotic system. And that's where, if that's part of your question.
Okay. More clarification. So you ask the question regarding methylation, and SNP is the single nuclear polymorphism. So in a biological science, this is a independent methylation versus single nuclear polymorphism can participate in that process. So it's more, I think is an independent concept. So in order to answer methylation, yes, they have different type enzyme genes. They could be some, SMP, single nuclear polymorphism. For example, different people have different gene, spectrum they can have involved. So when you ask these questions regarding maceration, mercury versus single nuclear polymorphism, I think a little bit, kind of different concept.
It was mentioned, I believe, that sulfur, when mercury binds it, sometimes, depending on the complex, releases free iron, which is dangerous. And Boyd, I think you've told me that can cause cancer or contribute to cancer. How do you deal with free iron? NBMI, I guess, is one way.
Well, the unique thing, that's what how mercury induces oxidative stress. If you treat an animal with mercury, mercury cannot make hydroxy-free radicals in the Fenton reaction. It's not a redox metal, but it displaces iron off the iron sulfur centers, and that iron is free, and when that happens, you end up making a lot of hydroxy-free radicals and damaging. Also, free iron is required for you to convert ATP to deoxy-ATP. That's a ribonucleotide reductase is a free iron requiring enzyme. If you chelate the iron, you can't make deoxy-ATP, you can't make DNA, and cancer cells will be slowed down in their growth rate. That's part of the idea behind it. And people have used iron chelators to slow the growth of tumors. And it works. It does slow it down, but then the iron chelation used it, and in most of the conditions is so lethal that it kills the patient itself. So NBMI, without having any toxicity, it has a promise there. I would not say it cures cancer or anything like that, but it has a promise of treating anything that's induced by excess free iron.
So in my previous studies, we compared metal, cadmium, arsenic, mercury, and we're using toxicogenomic approach to check why mercury, cadmium, arsenic, they can induce cancer because they are IRA, they recognize cancer. And we try to look at why mercury different from cadmium, different from arsenic. So from the point of the gene pattern, we compare different pathway oxidative stress. Yes, they both three metal induce oxidative stress. They change the cell cycle. However, they are different. So mercury is more kind of, they change the cell cycle is differently. They more, the gene change is not in the change is the DNA damage genes. So it's kind of very unique. So that's why mercury, hardly linked to increase of cancer. So that's why, in the final animal studies, compared to the cadmium arsenic, they are more, have the intensity induce cancer in animal, or either cadmium is also induce arsenic in human.
Questions, please come up to the mic.
Hi, my question is about people with G6PD. Can they take PQQ? Is it safe for them, or is it contraindicated?
No, PQQ is very safe with G6PD problems. It's the only thing that alters G6PD is DHEA, and I think vitamin C. So
any oxidative stress, including exercise, can, if you're G6PD deficient, can throw you into hemolytic crisis. Vitamin C, if given intravenously, not orally, can do it. Ozone therapy could potentially do it. Chelation therapy with EDTA can potentially do it. Fortunately, it's a pretty rare occurrence, but it's possible. Apparently not PPQ.
And do you want to try your mic and see if we can hear you?
No, sure.
We can hear you loud and clear, so jump in with all of the subjects while we got you online. Go ahead.
Well, it's actually been a little hard for me to hear you. I mean, to hear the speakers, there's a strong echo or reverberation. So there was a discussion, I believe, that had to do with single nucleotide polymorphisms and methylation of mercury. And I don't think I can add anything to what's already been said. So that's the only one I've actually been here for. So thank you.
But stay there.
So you were saying, Dr. Jorge, that the PQQ can be recycled quite significantly. So I'm just kind of wondering, is there any potential protocol to just load dose and then not take it for a while and then load dose again and allow the body to do that recycling, or is it a daily thing requirement?
PQQ is recycled through the glutathione system of the liver. That's where it gets recharged. And that's how it keeps getting recharged up to 20,000 times. So that I wouldn't just overdose and then go down. I would just give it a steady rate of material to go with, because who knows what else. It seems like, based upon what nature is doing, it's crucial for plants, crucial for animals, crucial for bacteria, that it's crucial for life, period. And I just have to question what else this stuff does. And it's crucial for the mitochondria of the heart, the brain, all the aging tissues of the body. Every one of us here is going to die from mitochondrial decay. And so, I think you just need to keep the pressure on the mitochondria to keep them reproducing as long as possible. Because your number of mitochondria as you're aging in the tissues is declining. When you take PQQ, the tissues start regenerating and making new mitochondria. And that's all under the influence of coenzyme Q10. I would not just take it and then stop, take it and then stop. I think I just want to keep a constant, steady flow going into the system.
Okay, thank you. The other thing, I guess, with iodine, I was going to ask, you discussed during pregnancy. What about, postpartum, like young children, infants, things of that nature? Is there any iodine protocols for younger children as they grow?
Yes, the human brain is in a constant state of, actually, as you are aware, the brain is made up either of neurons or glial cells. The glial cell system of the brain is stimulated by iodine. And the brain is under a constant state of development up until about age 8 or 9. Dr. Ben Carson, the neurosurgeon, showed us that if you have a child with seizures in one section of the brain, that you can literally cut off one half of the brain, take it out, and leave the other half there, and that other half will take over the whole body's function, as long as the brain has got that ability to keep developing. But that process stops at about age 8 or 9. Which basically says that continue the pressure on the brain with iodine until the kid is at least 8 or 9 years old. By then, the glial cell system is at its maximum capacity, and it will stop the continual development. From that point on, it's a matter of holding on to what you got.
And what dosage? What dosage then for children, do you think?
I think for kids, we give about 1 milligram per day up until about 3 or 4 years old. And then after that, we'll go up to 3. And then at about age 6 or 7, we'll go up to 6. And by the time they hit puberty, we'll go to 12. Because once the ovaries and the testicles activate, then you can hit them with a little bit harder with iodine. And what we're discovering is that iodine inhibits the ability of the body to make cysts inhibits the ability of the body to make cancer. It works as a great antioxidant to help stop development of some of these neurodegenerative diseases.
Thank you. And for Dr. Schallenberger, the melatonin, you discussed 60 milligrams 4 times a day for cancer, but I don't think you've discussed really a maintenance dose for that product for normal people, and if that perhaps varies depending on sun exposure and things of that nature, the natural production.
Well, we have very little to go on when it comes to melatonin dosing for humans. We just extrapolate from animal studies. And the animal studies, we can see a positive effect at human equivalent doses of down to 3 milligrams. So there are studies that with very low doses. When you get into the more serious types of neurodegenerative diseases like Parkinson's, for example, or dementia, the animals require larger doses. And when you get up into more difficult cases of cancer, they require larger doses around the clock. Normally patients with these kinds of diseases, there's no end to it. So there's no point at which you say, okay, we can reduce the dose now. I don't think you're ever likely to get to a point where you can actually reduce the dose. You're just in a holding pattern. Thank you. You're in a holding pattern, and we're trying to hold cancer bay. I think it's interesting, and I point this out to patients, that there's no cure for stage 4 cancer. So let's not talk about that. You're going to have it for the rest of your life. But it's interesting that for the most part, except when cancers are located in a vital place, for example, for the most part, the mere presence of a cancer is just not a problem. The problem with cancers is they don't stop growing. You could have 5, 10 cancers throughout your body, and some of us do and don't know it, incidentally, but you could have a lot of cancers throughout your body if they're not growing, which is true for a lot of people, maybe myself, walking around with cancers that are anatomically present but are not growing for whatever reasons. They're just not going to be a problem for me. So remember that. When you're treating these more advanced cancers, the idea is not necessarily to get rid of the cancer. In fact, the idea is never to get rid of the cancer, because you're not going to do that. But can you arrest the growth? Can you stop the growth of the cancer? If you can do that, that's about as successful as it gets, but you obviously can't withdraw the treatment.
This is probably more for Dr. Haley. Mercury detox, of course, is a big topic for a lot of us, a lot of mercury poisoning out there. And in the 1990s, the mindset was we had to use DMPS or DMSA. And I think in your Savannah PowerPoint presentation, you addressed some of the problems with them as chelators of mercury and said they're not real chelators of mercury. I think that's worth explaining a little bit, maybe, because you didn't touch on it today, I believe. And of course, that's why you went on and invented NBMI, because you were not feeling like the ultimate answer for chelating mercury existed before you did that. So why don't you say something about these other so-called chelators and what the problems are with them, because I think it's such important information.
Well, the fact is DMPS and DMSA are not chelators. They're not true chelators. They form sandwich complexes with mercury. And if you look at the structure, and it's been proven, this has been done by the 2 sulfurs on adjacent carbon atoms.
Yeah.
Do not leave enough space in between for you to form a 180-degree bond with mercury. And the structures that people draw on a piece of paper with DMPS chelating mercury just can't happen. The mercury atom's too big to fit in there. And when you look at the compounds that are produced and removed in the urine with DMPS and DMSA, they're sandwich complexes. In other words, for every mercury atom will have 2 molecules of DMSA or DMPS on them. And so they're not that. But that's not really their major problem. Their major problem is they're charged, and they do not get inside cells, and the mercury toxicity that's affecting most people is inside the cell, and sometimes even on the mitochondria, or in the mitochondria. Right. And that's where you have to get, and DMPS and DMSA do not get there, and neither does EDTA, at least not effectively enough to detox these compounds. And whenever you have a single bond to mercury, that compound that's forming the single bond can exchange very quickly. And it's all electron withdrawing properties. It's pretty heavy-duty chemistry. But when you can get two sulfurs at 180-degree bond, none of those electrons on the mercury will ever be exchanged off. And that's, I think you talked about the fact that the disulfides bind the mercury tightest if they can form a two-mercury complex. Maybe you'd like that.
I talked to somebody attending here who said he took DMSA 40, or his son took it 40 rounds, he took it 20 rounds, and he wasn't doing well, but his naturopath said he had to do it that way. And I just thought, well, you're kind of trapped in the 1990s when we thought that was the only thing you could use. And but you point out, and I think it's so important to point out the deficiencies of these old chelators. Another thing that some of the gurus tout is alpha-lipoic acid, and maybe you could address that too, because that's not, as I understand it, a good chelator of mercury either. And so say something about that, and we have to be honest about what doesn't work as well as what is going to work better.
Well, the problem you have with compounds that form weak bonds with mercury, such as DMSA or DMPS, when they form the sandwich complexes, is that they exchange readily. And you can take rats that are somewhat mercury toxic and you can kill them by trying to chelate them with DMPS. And they have done this because it will translocate the mercury from the liver and all the other tissues and concentrate it in the kidney, which has the more reactive thiols. And so you die of renal failure because you're moving the mercury out and it goes out through the kidney because it's negatively charged. And so you have a real problem with that. And I don't see how lipoic acid, lipoic acid binds mercury, there's no doubt about it. That's the reason mercury inhibits the first step or the last step of the citric acid cycle, because it takes the lipoic acid and renders it non-useful. But I don't think that I would think that lipoic acid would be a good way of moving mercury out of the body. I know some people have made that claim, but I haven't seen the research that would back it up. It's a good try, but the research just doesn't back it up.
Mm-hmm. So you
lipoic acid, when it binds to mercury, that would make a six-membered ring. A six-membered ring does not have 180-degree capability of binding mercury, and therefore that is a stressed bonding of mercury into that
so it's not really a real chelator of mercury either, as some have claimed. Okay? So it's not a real chelator of mercury either, is what you're saying. Alpha-lipoic is not. I mean, some claim, well, you can just go with alpha-lipoic as your chelator.
Well, you understand what a chelator means to a chemist. It means that the one molecule surrounds it and binds it from two sites. I don't think lipoic acid would do that. I think it would form linear sandwich complexes.
Right. Yeah. And Quicksilver Scientific's products, just deal with boosting the body's glutathione system, which is probably a safer, gentler, more natural way to go at it. Wouldn't you agree? Any comments on that?
I'm sorry, but my hearing on certain tones is not very good, so I didn't hear what you said.
Chris Shade, Quicksilver Scientific's approach is to boost the glutathione system, and not only glutathione levels, but also the glutathione S-transferase and other enzymes that are part of the system. So does that look like a more gentle, sound approach to detox, as opposed to these drugs which can just redistribute the mercury?
Well, the natural way to get mercury out of your body with nothing else around is to bind it to glutathione. But it forms a sandwich complex with glutathione, two of them on there, and it marks it and has it carried out. So And if you can activate glutathione S-transferase, that'll help you detox a lot of things. But you don't need glutathione S-transferase to get rid of mercury.
Right.
I mean, mercury will bind to two glutathione molecules without any help from anything. And
very good.
So.
Yes, I think Anne has something to say about this. Can you?
Yeah, I had a question. Actually, I wanted to jump in on this lipoic acid subject. Can you guys hear me? Just wave if you can hear me.
Very well.
Okay, thank you. Actually, the six-member ring is not a priori an impediment to forming a 180-degree or other kind of bond that would be stable for mercury. Certainly the proteins that we're looking at that Stephen showed earlier this afternoon that have two cysteines spaced usually 2 or 3 nucleotides, amino acids apart, those are going to make even larger rings. And there are some proteins that we have found, peptides, where the cysteines are even farther apart, but they make stable bonds to mercuric mercury. So I think, as you said, the jury's still out. Nobody's really asked the question about lipoate. But I think the bigger issue with lipoate is, in terms of being a natural response or a natural detox, it's not, there's no free lipoate in the cell. It's made on the protein that it serves. And in terms of normal biology, in other words, a cell will have a protein that it builds lipoate onto that protein. So it's just for that particular, like lipoamide dehydrogenase, for example. That is built on the protein. However, people have made, and it's widely marketed, there is synthetic lipoate that's widely marketed, and I believe it's even used by prescription for some condition, might perhaps be diabetes or something like that, I don't remember, in Germany. So those are the two kind of roles that I'm aware of that lipoate has. There's the natural one, where it's not ever free as a free molecule inside of our cells. It's built onto a protein that uses it. And then the other use is this marketing of lipoate as a commercial product, a nutraceutical, if you will. And in that case, the metabolism of it is actually, I mean, it does have positive effects that are apparently sort of like redox protection, but it's not clear that it's actually lipoate that's doing that. It may simply be stimulating the other natural, like glutathione or cysteine overexpression. So that's a little bit fuzzy as far as I can tell from the literature right now. It's a very interesting question and one that should be asked, but like I agree with Boyd that I haven't seen anything where anybody's specifically done any serious biophysics on lipoate. It's an intriguing question, I think, and one that deserves attention.
Thank you, Ann.
I have a question. I'd like to follow up on that a little bit. The chelators that we've just been talking about don't work intracellularly. You made that statement, right?
They don't get inside the cells.
Yeah, they don't.
Not effectively.
Yeah, okay. But what is inside cells is glutathione. And so it would seem to me, and I'm really asking a question, but it would seem to me if you had enough glutathione intracellularly, this would handle mercury toxicity. My question to you is, what do you think of that? Number two, when the mercury interacts with glutathione, what happens then? Does the glutathione exit from the cell, mercury in tow? Is that what happens?
Well, number one, the first time when you become mercury toxic, the first thing that happens in your cells is your glutathione levels go down the toilet. And your glutathione S-transferase and the glutathione synthesizing enzymes get inhibited, and you become very short in glutathione, so you can't transport it out. And when glutathione binds to mercury, according to the research I've read by Clarkson, it forms a sandwich complex, and whenever you put glutathione on any toxin, it's using the P450 system, you put glutathione on hydrophobic toxins, and then that marks that thing to be carried out of the cell, and when it's out of the cell in the blood, it's picked up by the biliary transport system and put into the bile and into the feces. I mean, if you look at the glutathione concentration inside a cell, it's in the millimolar range, 5 to 8 millimolar, something in that range. In the body, in the blood, glutathione concentrations are 1 micromolar. They're in the low micromolar range. And the reason for that is that whoever created the human body, God or however you want to look at it, he used glutathione as a marker to put on something, to attach to something through the P450 system, so that compound would be marked for excretion. Because when you go through the bile and through the biliary transport system of the liver, if it has a glutathione on it, it gets bound and immediately excreted into the bile. That's the reason giving glutathione IV doesn't work, because it gets them removed from the blood by the liver very quickly, because there are sites in the biliary transport system that have very, very high affinity for glutathione, and it makes a 1,000-fold difference in the concentration inside the cell versus outside the cell, because that's the way the system works, so we can detox with glutathione. I don't know if that answers everybody's question.
So to follow up a little bit again, presuming that you had enough glutathione, you're going to pull it out of the cell into the periphery, where things like lipoic acid, DMPS, DMSA can also sandwich it and help to escort it out, along with a high-fiber diet, perhaps, through the intestinal tract, through the enterohepatic tract, maybe even in the bloodstream. But the whole thing is key upon having enough glutathione. So how do we get I know ozone stimulates glutathione, something like 300%, but, I'm sorry?
Go ahead and finish your question. Sorry, I didn't mean to interrupt you. I just wanted to kind of get on the list. So you were finishing the question.
Okay. Yeah, so the question for me is, how do we get enough intracellular glutathione? How are we going to do that?
Well, one, you cannot. I mean, you cannot have enough intracellular glutathione if you're mercury toxic, because it inhibits the enzymes that recover it and the enzymes that synthesize it. Mercury, the first thing, and the reason mercury is so damn toxic, it depletes your body of glutathione. That's the first thing it does. In every cell study I've ever seen where they've added mercury, they said, what's the effect on the tissue? The first thing that happens is that the reduced glutathione levels go down the toilet.
Right, and there's 2 ways that can happen. One way is for mercury is toxic by binding to sulfur groups on proteins, and also low molecular weight compounds that are metabolically important, like glutathione, S-adenosylmethionine, and so forth, are other things that are metabolized that get hit by mercury directly. But as Stephen mentioned earlier today, once you hit the electron transport pathway, then you begin to get the generation of redox active compounds by destabilizing the homeostasis in the electron transport pathway, and you get a burst of reactive oxygen species. In other words, you mess up all of those enzymes and they start going wacky and they make superoxide, and then you get, superoxide dismutase functioning to get H2O2. You've got H2O2 and iron around, free iron around. Then basically you have this burst of other kinds of damaging reagents that are not mercury. All you have to do is mess with the ATPase, the proton translocating ATPase that does those oxidations in the membrane, and you will get this burst. And that's been shown many years ago in the mitochondrion, that the mitochondrion is really the source of all of these things, because it's doing electron transport and synthesizing ATP for us. But if we whack it, it's very delicate enzymes with mercury, we'll get a burst of, and so a lot of nobody's actually done the stoichiometry on this, but it's very likely that the reason that we are so sensitive to very low levels of mercury, much lower than the buffering capacity of the glutathione, because glutathione is around millimolar, like 5 to 10 millimolar, depending upon the compartment of the cell that you're looking at. Dean Jones at Emory has shown that there's actually gradients of glutathione. The Golgi is very low, comparatively low in glutathione, because it has to make disulfide bonds for proteins that need disulfide bonds. But much higher glutathione is found elsewhere in the cell, and certainly in the mitochondrion. So millimolar glutathione in our cells, but oh my gosh, we're sensitive to micromolar levels of mercury. What's going on? the mercury that first hits the cell damages this wonderful electron transport pathway that we have, and it shoots out a lot of reactive oxygen species. And those reactive oxygen species are also important in damaging and depleting the glutathione pool. So it's a combination of things. There's those two kinds of damage. The damage that we focus on, we've noticed, I mean, we pay attention to both of them. And I think one of those, I can't remember right now, but one of the slides that Stephen showed the depletion of thiols in the cell. Both the thiol, I guess we didn't show you that table, but definitely can show that the low molecular weight thiols are also going down. But the slide he showed was that the thiols on the proteins are also being blocked. Those aren't all necessarily being blocked directly by mercury. They could simply be oxidized by the electron transport releasing reactive oxygen species when the first mercury hits the electron transport pathway.
I would just say that, from the studies done on mercury and this effect on the electron transport system, if mercury displaces iron off the electron transport system, then you start having a lot of leakage of electrons and you start forming a lot of hydroxy radicals, and then the iron along with the superoxide anion that's produced in a damaged electron transport system starts making more hydroxy radicals, which also depletes the glutathione. It's a lot of the process. So it's not, glutathione isn't depleted just by binding mercury. It's depleted by, yeah. I agree with that.
To sort of go back to the point that you were talking about, the association of mercury with glutathione. Certainly it is associated with some glutathione, but there is also a huge amount of it that's associated with proteins. And in terms of when you're talking about acute mercury exposure, yes, the glutathione is gone, perhaps because of the damage of the reactive oxygen species, but what mercury is very likely bound to in large amounts are the protein thiols in the cell, which by our measure are at least half of the available thiol groups that one can measure with standard reagents. In other words, there's a lot of binding sites for mercury that are on the proteins. So with respect to how those get out of the cell and where those go, which is kind of where the preceding question was going, that's a little trickier. It's not something that necessarily is going to be handled by the standard, phase 1, phase 2 detox processes. So that's why mercury builds up. That's why mercury is bioaccumulated in higher organisms, not just in fish, but also in us, as Dan Lax showed many years ago using the NHANES data. The older you are, the more mercury you're carrying in your blood. And that's not simply going to be on glutathione. Glutathione's a player, but it can so easily be knocked out. And if you're talking about acute mercury exposure, which is certainly what people get from amalgams, then you're talking about, oh my God, it's stuck on a protein now. What do we do with that protein? Or those many proteins, as Stephen showed, in many metabolic pathways. And so that is a challenge that is not, in fact, well worked out.
Well, I would agree, that, and I think it's common knowledge that when you get exposed to mercury, you're a biochemical train wreck. There are a ton of enzymes that are inhibited, but the ones that really cause you to die are the ones that deplete you of glutathione because you can't get rid of it. Even the red cell has glutathione to try and get rid of it, but if it binds to the outside of the red cell, that glutathione is not going to get near that mercury and deplete it. It's a very complex problem. So, somebody else.
Yeah. This brings me to another question I wanted to ask you, Boyd. You sort of hinted in this in one of your slides, and that has to do with whether or not the complex of mercury and NMBI in feces is actually a complex of those two together. And I gather that you have only recently been able to put together the analytical tools for asking that question. I may have misunderstood your slide, but I hadn't seen that. And I think you were sort of hinting in one of your slides that you were now able to do that. I wonder if you could comment on that.
Well, the key is, you can make NBMI mercury in a test tube. And you cannot get that mercury off of there. You have to go to 237 degrees centigrade and destroy the structure of the NBMI to get that mercury released. It will not react with anything. It will not dissolve in anything. And the only thing that allows the body to get rid of it is to hydroxylate the aromatic ring and attach something like glutathione. Well, and I think it's glutathione. We haven't determined that yet. We're working on that now. And the reason I think that is because it goes out through the feces. And anything that's labeled with glutathione, like viral particles, etc., go out the fecal route because there are receptors in the biliary transport system to pick up anything labeled with glutathione and clean it out of the blood. And so, a lot of it is speculation, but the fact is it all goes out through the fecal route if you label it with NBMI. And otherwise, a lot of it will go out in the urine.
Have you looked at metabolites of NMBI to see that their affinity for mercury is equivalent to unmetabolized NMBI or NBMI? Because it's going to go, when it goes through the liver, it is going to be modified. And I don't know if you know what the modification products are as it goes through the liver and into the feces.
You mean for NBMI? Well, one thing we do know is that NBMI, mercury, is a substrate for a class of CYP enzymes that put a hydroxyl group on the aromatic ring.
Okay.
Now, what gets added? You can either add to that sulfate, glutathione, or uridinylation. Those are the three things that are used in the phase 2 of the P450 system. And the one that takes it out through the fecal route almost exclusively is the glutathione. And mercury bound by NBMI is almost invariably it goes out through the fecal route. So there's some speculation. We haven't proven this for sure yet, but it looks like that's the way it's going to be.
Is that okay? Yeah, okay. Regarding the alpha lipoic and either oral, like say 200 milligrams a day, or IV, as somebody like Dr. Berkson of New Mexico has touted in treating cancer, for example, because it enhances the mitochondrial function. So if somebody has either cancer or some sort of a toxicity like mercury toxicity that would interfere with alpha lipoic, would that be advisable, either oral or IV alpha lipoic? Thank you.
Somebody tell me what his question was, because every
He's wondering if the alpha lipoic acid is being used IV to treat cancer at 200 milligrams, I believe.
No, I said orally, say 200 milligrams or something like that, or IV would be 100 to 600, depending on the patient, which has been used by Dr. Berkson to treat, say, pancreas cancer and whatever, with some good results in New Mexico, but also particularly because it's a enhancer of the transport into the mitochondrial. So either regarding cancer or regarding any other toxicity, for example, mercury toxicity, would it be advisable to advise, like, for example, there's a lot of literature that says, take alpha lipoic for detox or things like that. Is that advisable, do you think?
I'm not quite sure what this is about, but is it advisable to use lipoic acid?
Alpha lipoic acid, take it orally, for example.
Is it advisable to take lipoic acid orally?
Yeah, because one of the things
not?
that was,
Why not take it orally? Well, you're concerned about something.
Because it was just brought up about the alpha lipoic being chelated or chelating or being chelated by mercury.
Oh, geez. That doesn't seem like it's a problem to me. Our bodies synthesize lipoic acid and release it into the bloodstream. We make glutathione, release that into the bloodstream. All of this translocates mercury. I don't think that's a horrible thing to do. The problem is with chronic illness, we chew up a lot of all that lipoic we make. It's kind of like what Boyd was talking about with glutathione, same idea. all the reactive oxygen species just chew up glutathione and lipoic acid like crazy. It's sort of like you can't do enough things to raise the levels of those. I personally don't think that's a problem. Do you think translocation of mercury
But is it
an issue?
helpful?
Well, it depends on how much you're taking. I mean, translocation it's a matter of concentration. I mean, when you talk about glutathione in the cell, that's a very small volume compared to the glutathione in the blood, or the volume of the blood, etc. So there's some problems. But it would be, depend if you're taking grams of it and you don't know your body's not used to having grams of it around, it can have a different effect in the level because the body regulates how much you can make and how much you would make. So that would be the only way I would see that would cause a problem. But you can't translocate. If you get something that gets into the cells and binds mercury, it can translocate the mercury, and that's one of the big concerns if you're treating mercury toxicity, is taking it out of the liver and concentrating it in the kidney. That's what would be the concern. And I actually haven't read any papers when anybody's tried to take the lipoic acid and use it that way. I mean, I just don't think it would bind mercury that tightly.
Thank you so much. Anne, thank you for being with us.
Thank you guys for making it possible.
Bye-bye, Anne, and thank all the speakers for coming back this afternoon and answering the questions for us. Thank you for being here. At this point, we're going to show the Jerry Tennant lecture on video. Dr. Tennant was not able to make it to the meeting, as you know. If any of you want to stay and watch the video, you're welcome. It's going to be shown right away. How long is it? I think it's just under an hour. Just under an hour. And after that, I think there's in the Hawthorne Grill, there's a meeting. Say again?
The code for this? I don't know the code.
Oh, the code. Say again? FF. SF, like San Francisco again? 1789. Okay, same number as all day, 1789, and SF Speakers Forum, SF San Francisco Speakers Forum, 1789. Thank you, Dr. Yu. Thank you, Dr. Haley. Pleasure meeting you. Thank you for coming today.
This is Dr. Jerry Tennant. Today I'd like to discuss with you the issue of the physics of emotions and the role of emotions in chronic.
Dr. Tennant's presentation will be 45 minutes, not 1 hour.
Disease. Before I do that, however, I must disclose my interests. I may hold patents on certain medical devices and receive royalties from my devices and books. I often have travel expenses supported by Synergy Medical Group and others, and I may receive an honorarium. It is likely that anything that is attached to my name, that I will have an interest in that subject or that device. I always begin my lectures by noting that Tenet Institute is a private expressive association as defined by law and is under the direction of Jerry Tenet, MD, MDH, PSCD. This lecture is given under the auspices of my Arizona MDH license and not my Texas MD license, partially with the support of